As far as signals and systems is considered, signal operations plays very important role. Alternatively, the mechanism is also referred as signal transformation. So in this small presentation, we will discuss related with signal operations, that is time reversal, time shifting, time scaling, and even odd. That means even odd classification, as far as we have defined already how signals are classified, or what do you mean by even signal or odd signal. But with that, as far as transformation or operation is considered, there is a specific mathematical operation which is performed to find out even part of the signal and odd part of the signal. So that small discussion also we will do in this presentation as an illustration part. Okay. Next is say time scaling we want to do. So the signal is, say for example, y of t, which is equal to x of at. So with respect to time axis, we want to scale the signal. The time scale version of x of t is maybe, say for example, a is greater than 1 or a is less than 1. So when a is greater than 1, then we are speeding it up. So we are making it faster. Okay. So when we double the duration, that is we are making it with twice of the speed, our signal is going to get compressed, and whenever we make it half, or say for example less than t means say t upon say some that, but 1 upon a some number, maybe 1 half 1 by 4 or whatever. So at that time the signal will get expanded. So it is exactly a reverse thing. That is, when a is greater than 1, we are multiplying t by factor a. So say for example, after multiplication, you may find that graphically if we plot, then the signal is going to become more faster. So x of t, so whatever is now happening at say -1, 0 and 1. So x of t is -1. Now suppose a we are taking 2, then x of that is 2t is equal to -1 now. So therefore t is equal to half, -1 by 2. Now here you can see that particular point. So whatever was earlier happening at -1, now that is happening at -1 by 2. On the same line, 2t is equal to +1, then t is equal to +1 by 2. That means it will get again shrink. So at 1 by 2. So earlier, if this cycle we are taking as a specimen -1 to 1, instead of that now it is happening from -half to +half. Whatever is happening at -3 to -1, now that is going to happen from this particular -2 to -1. So like that. So it is going to be shrinked. So this is scaling. A is greater than 1, it is going to speed up smaller period, and graph is going to get shrink. And whenever a is less than 1, so at that time it will take more time, and therefore graph is going to get expanded. So this you have to remember. So here period is 2. So here it is from for -1, whatever is happening now, that is going to happen at -2, and ultimately whatever is happening at 5, now that is going to happen at 10. So this is in between some points. If suppose we consider for reference, then it will look like this. Same fashion, if we are making it minus, that is the reflected version, then also whatever is at -1, now that will happen at +2, because we are making it minus t by 2, and there is a reflected version. So here there is a combination. So there is a scaling as well as reflection. So this signal you can see the scaling and reflection. Now here also, say for example, one more I have taken yt, y of 3t and y of t by 3. So signal is from 0 to say 3. So whatever is earlier happening at 0, now that will happen at 0, no doubt. But whatever is happening at 3, now that will happen at 3t is equal to 3. Therefore t is equal to 1. That means it is going to happen at 1. It is going to finish it up 3 times faster. So this is faster version, and that's why time wise signal is going to get compressed or shrink. Exactly opposite, that is when it is t by 3. So when it is t by 3, at that time what is happen? T by 3 is equal to 0. Therefore t is equal to 0. That is the lowest boundary of this original signal, and uppermost boundary we will consider as 3, and at that time I will write t by 3 is equal to 3. Therefore t is equal to 3 into 3, 9. So that means it is going to become or slower. It is 1/3 rate. Okay, this is 3 times faster and this is 1/3 times say slower, we can say. So it is going to slow down, and that's why it is going to take much more time along time axis. So that is the expanded version. Now as far as shifting is considered, so you can have a simple shifting effect, like here also you can see. So t minus t0 we want to shift. So this is our original signal, -1 to 5. Now whatever is happening at the -1, now we want t minus t0. Say for example by 1 unit we are going to shift. That is, here we are calculating t minus 1. So whatever is happening at -1, t minus 1 is equal to 0. Therefore t is equal to plus 1. Same fashion. T minus 1 is equal to 1. Therefore t is equal to plus 2. T minus 1 is equal to 2. T is equal to 3. Like that. And t minus 1 is equal to 5. So therefore t is equal to 6. So here it is 5 to 6, new value. 4, 5 minus, don't take it minus, just as a reference interval we are mentioning. 3, then 4, 2, 3, 1, 2. So whatever is happening at -1, now that is going to happen at here. You can say 0. It is going to get shifted. Here it is -1. Then it is new will be 0. So like that you can have the signal shifting, and this is delay. That is t minus t0. This is a delayed version. Then say for example here t minus t0. Now whatever may be t0, plus minus whatever is its value, so accordingly it will get shifted like this. It is going to get shifted. So when t is greater than 0, it is going to get shifted in the right half. When t is less than 0, so it is going to get shifted in the left half. So this is as if lagging behind, this is leading, going ahead. So this is ahead and this is lagging, or we can say that signal delayed is going to generate right shift. Signal advanced is going to generate left shift. Advanced is plus T0. So here it is plus T0 and delayed is minus T0. Okay, but in actual it looks, when it is minus T0, it is in the right half getting translated, and depending upon the signal occurrence. So say for example already signal is at far end in the negative half, then though we are going to do right shift a few say units, still it may lie in the left half itself. Okay, left half, sorry. So it is nearby minus infinity in that region, and then slightly we are sliding or allowing the signal to get translated. So it will take much time to enter into the right shift. The only thing is that with respect to its previous value, it will be at the right side, more towards right. That is minus or delayed version, and more towards left, it is advanced version. So plus shift factor. So this also you would remember. Say for example here we are doing, so t minus t0, t plus t0. So anything you can have, and accordingly you can calculate. So u of t plus 2 and u of t minus 2. So like that we simply make it. Then maybe you have something as a, say u of t greater than 0, 1, then equal to 1 half for t equal to 0, say for example, and 0 for t less than 0. So this way also you can express it, and you can have like time wise some sort of a signal operation. If we want to draw this u of t plus 1 and u of t minus 2, so t minus 2 is going to be somewhere here, like in the 2 units right side. T plus 1 is left side, it is coming back, so it is in left half, and its subtraction if we want to do, then from this you can subtract. So whatever is the remaining portion that will appear, rest of this portion will get vanished. So from this unit to this unit, only the signal will remain and rest of the signal will get cancelled. So this way you can perform. We are here. So this way we can do this. Here it is. So x of 2 minus t, and we have clubbed x of t plus x of 2 minus t. So that is addition. Original signal and then added version. You can have like this: delayed, advanced, reflected and delayed. So in number of operations. This way you can have reversal, scaling, hmm? like reversal in the with respect to amplitude. Also you can do minus sign, minus of x of t. That also, x of minus t is mirror image in the horizontal plane, and minus of x of t is mirror image but in vertical plane. So like that. Here you can have a scaling. So this is multiplied by 2, so 2 times. Here it is made half, so 0.5 times. So like that also we can do. Then something like this also we can do. So one is this unit step signal, this is x of 2, and 1 minus x of 2 we are doing. So this minus this, so this portion, middle portion will appear here, and this will be minus. Then multiplication we can do this signal and this signal, x of 2 t and u of t. So when we multiply, so multiplication is, see here, before 0 there is no u of t portion existing, so therefore that is 0, and though 0 multiplied by something 0, and only from 0 to 1 this signal is existing, so therefore when it is multiplied by 1 this signal will appear as it is. Here you can see the different effect, because here what is happening, this signal is 1 all over. Say for example, they have shown all over as an example. So therefore up to minus 1, only one signal is existing, we will draw it with unit 1. So this portion will appear, this straight line. From minus 1 to 0, from minus 1 to 0, this signal is 1, but this signal is minus 1 to 0, it is rising from 0 to plus 1. So when at minus 1 this is 1, this is 0. Therefore at minus 1 resultant is 1 minus 0 is 1. And at 0, when this is 1, this is also 1. So 1 minus 1 0. That means from minus 1 to 0, it is coming down from 1 to 0. On the same line, from 0 to 1, from 0 to 1, this is 1, and from 0 to 1, this is coming from 1 to 0. Therefore, at 0, 1 minus 1, therefore it is 0. At 1, this is 0 and this is 1. Therefore, again at 1 it is becoming 1. Therefore, from 0 to 1 it is rising, that is, it is becoming going towards 1, that is from 0 to 1 it is also becoming 1. So linearly it is a ramp. So this is signal addition, subtraction or multiplication kind of operation. So this we can do. 6. So simple thing is even and odd signals, x of t is equal to x of even t plus x of odd t. So even component plus odd component, total signal. Then x of even part we want to calculate, then it is to be calculated as 1/2 of x of t plus x of minus t, and odd part x of odd, that is equal to 1/2 of x of t minus x of minus t. So this way you can calculate same thing. And if two even signals are multiplied, then the resultant, odd signals are multiplied, then the resultant. So we can make it t and minus t. On the same line, here you can have x of minus t and minus t, one is odd, so therefore the answer is coming odd. So that way we can have. So this way with your unit step also you can have some sort of simple modifications, nothing very specific, so just I am skipping it. The characteristics. This way it is the reflected version. Then even part. So even part is this plus this, u of t plus u of minus t. So this way, and its subtraction is u of t and minus u of minus t. So this way, and if these two are added together, 1/2, here also 1/2, here also 1/2. So this negative half, this portion minus 1/2 and this plus 1/2 completely will get cancelled. At 0 this is 1/2, at 0 so resultant will become 1, this 1/2. So skip this because of this portion it is going to get cancelled, so it will become 1, and rest of the part 1/2, this is also 1/2, so resultant is 1. So this is from u of t, x of t, x of minus t, or u of t, u of minus t, and its even part, and this is its odd part. Same style simple operation you can have. Say one is u of t, one is ramp function, and maybe one shifted version. So you can draw like this. Just a simple operation I'm illustrating. This is u of t, this is r of t, and with minus sign, so it is appearing like this, and plus r of t minus 1, so it is going here. So in this portion, first of all it is going to become 1 because 0 plus 1, and now this part and this part up to this point, okay, what will be the effect? This is 1 and this is something minus, this is every time it is coming down, this minus this minus this, so that's why this portion it is coming down, and somewhere here r of t at 1, say for example, since it is a plane ramp, so at this point this will be also 1, from 0 to 1 it will also become 1, and at 1 this is also 1, so 1 minus 1 it will get cancelled here, and this is 0, okay, and whatever is the remaining portion from this point, it is r of t minus 1, so it is going to, this line will come down directly, it is not coming down means not here, just I am showing, and r of t minus 1, because this portion, your u of t minus r of t is this portion, and then r of t minus 1, so like that it will go. One more for even odd, so here it is, say for example this signal, now it's x of t plus x of minus t, okay, so this will be like this, and x of t minus x of minus t, so it is going to get added, this is added and this is subtracted version. So if once again if these two are combined, then you will get the original signal, getting? So this way you can have. Thank you.